Okay, in this video I will show you the famous formulas of the Atwood machine without uh, considering the moment of inertia of the pulley. In this derivation you will show how to get the magnitude of the acceleration and the magnitude of the tension. Because the magnitude is a positive number, in this derivation it is assumed that M1 is bigger than M2. Okay, so this is the Atwood machine. M1 is bigger than M2, so the acceleration of 1 is going to be negative, and the acceleration of 2 is going to be positive. But they are connected by the same string, so it can be shown that the accelerations are equal but opposite. So A1 as a vector is opposite to A2, but the magnitudes are equal. So A1, that is going to be, when we are going to put it in Newton's second law, remember it's a vector, and we are going to use it on Newton's second law, is going to be -8, and A2, when we put it in Newton's second law, is going to be positive. Okay? That's the first thing to consider. When one is going down, the other one is going up. Now let's do the free body diagram of object 1. We have tension and M1G, and for object 2 we have the same thing, tension and M2G. So now we are going to put the Newton's second law in the y-axis for each object. So over here we have plus T minus M1G equals M1 times negative A, its value over here. And here we have plus T minus M2G equals M2A, this value over here. Okay, remember this is A1 and this is A2. Now, this is a system of two equations, two unknowns. We want to find the acceleration of the object, each one, and the tension on the string is one string. That's why I didn't put T1 and T2. All right, so I think the equations now, I will multiply by -1 on 1. Let's say this is 1 and this is 2. So -1, the first equation times -1, so I get negative T plus M1G equals M1A. Okay, and now I can easily add these two equations because you see the tension cancel out. So let me put this one over here. And this cancel out and I get M1 minus M2, common factor G, M1 plus M2, common factor A. So here we get an acceleration that is G times this difference divided by this. So you could, if you make the masses very close, Okay, so this is the equation for the acceleration of the object. Again, if m1 goes down, so acceleration is negative, that value, and 2 goes up, so the acceleration is this. Now let's find the tension of the object. So we could use either equation. I will use equation 2, so T equals m2g plus m2a. Take m2 common factor and substitute acceleration we got. And now we could take g common factor, and this is 1 plus the difference over the sum. I can put m1 plus m2, 1 plus m2 plus m1 minus m2. This cancel, and you get m2 over m2g, 1 plus m2, 2m1. Alright, so the tension is 2m1 m2 over m1 plus m2 times g. And this has units of mass because it's mass squared over mass. And this is the tension of the object.